In this second exercise, we will learn how to calculate the relative risk with 95% confidence intervals for the association between maternal vitamin B deficiency and infant low birth weight, which is defined as less than 2,500 grams. There are three exposure categories: those women who have normal levels with no deficiency, those who are low in exactly one vitamin, and those who are low in 2 or more vitamins. For each exposure group, we are provided with a total number of births, as well as the number of children with low birth weight. In the first question, we are asked to construct a 3x2 table for the given data. We first start to make a table where the rows represent the three exposure categories and where the columns represent the outcome categories. We then fill in the total number for each exposure group and then the corresponding numbers of low birth weight infants. To find the numbers of infants with normal birth weight, we subtract the low birth weight numbers from the total numbers of birth within each exposure group. This will complete the 3x2 table as requested. In the second question, we are asked to calculate the incidence risk of low birth weight for each exposure group. As there is no information about the per sample number, we choose to calculate the incidence per 100 sample, which will give us the percentage. Starting with the first exposure group, we simply calculate the ratio of the number of infants with low birth weight, which is 36, and divide this number with the total number of births in the same exposure group, which is 1,691. To get the percentage, we multiply the ratio with 100. In doing this, we find that the incidence risk of infant low birth weight for the first group is 2.13%. The incidence risk for low birth weight infant among women who were low in exactly one vitamin is 3.79. For those who are low in more than one vitamin, the incidence risk for infant low birth weight is 4.76. In the third question, we will use the incidence risk above to calculate the relative risk for the association between maternal vitamin B deficiency and infant low birth weight. We are asked to use the unexposed group as the reference group. This means that we will use the first exposure group as the denominator for the two other exposure groups. In other words, we compare the incidence risk for those exposed with those unexposed. Following this, the relative risk for low birth weight infant in the group who were low in exactly one vitamin is 3.79 divided on 2.13, which equals 1.78. Using the same formula, the relative risk for low birth weight infant in the group who were low in 2 or more vitamins is 4.76 divided on 2.13, which equals 2.24. In other words, those who are low in exactly one vitamin had a 1.78-fold higher risk of having an infant with low birth weight compared with those who had normal vitamin B levels. Those who were low in 2 or more vitamins had a 2.24-fold higher risk of infant low birth weight. In the fourth question, we will calculate the 95% confidence interval to establish whether our results are precise or not. If the results are precise, the 95% confidence interval will be narrow. In addition, if the interval does not overlap 1, we can conclude that there is statistical evidence for an association between vitamin B deficiency and infant low birth weight. Otherwise, we must conclude that the results are uncertain and inconclusive. The formula for the 95% confidence interval for relative risks is provided in the lectures. To estimate the 95% confidence interval for the relative risk of infant low birth weight in those who were low in exactly one vitamin, we will use the numbers highlighted in green. By using these numbers, we estimate that the 95% confidence interval is from 1.09 to 2.89. Because the confidence interval does not overlap 1, it is likely that the deficiency in one vitamin can increase the risk of low birth weight in infants. To estimate the 95% confidence interval for the relative risk of low birth weight in those who were low in 2 or more vitamins, we will use the numbers highlighted in yellow. In doing this, we estimate that the 95% confidence interval is from 1.28 to 3.90. Again, because the confidence interval does not overlap 1, it is likely that the deficiency in 2 or more vitamins can increase the risk of low birth weight. Finally, we are asked to conclude. So, as both exposure groups appear to increase the risk of infant low birth weight, and that the relative risk increases with increasing number of vitamin deficiencies, we can conclude that it is likely to be an association between maternal vitamin B deficiency and infant low birth weight.